are special types of angles. These are particularly important because these are the angles that are formed when parallel lines are cut by a transversal. So in the picture here, we have two parallel lines. The blue lines are parallel lines, meaning, of course, we should probably already know this, parallel lines are two lines that never touch or intersect in any way. They're cut by a transversal. The transversal line is just a red line pictured that goes through the two lines. When that happens, some special angles are formed. Those are listed over here on the right. Alternate exterior angles. This tells you, the name of the angle tells you exactly where it is. Alternate means on alternate sides of the transversal, so they're on opposite sides of the transversal. Exterior means they're on the exterior of the parallel lines. So take a look at these. Angles 1 and 7 are alternate exterior. They're on opposite sides of the transversal and they're outside the parallel lines. Angles 2 and 8 are also alternate exterior angles. They're on opposite sides of the transversal and the exterior of the parallel lines. Their property is that they are congruent. Okay, so angle 1 and angle 7 are congruent. Angle 2 and angle 8 are congruent. Another special type of angles formed are alternate interior angles. Okay, alternate again refers to position along the transversal, so they're on opposite sides of the transversal. Interior refers to the parallel lines, so they are on opposite sides of the transversal, but they are inside the parallel lines. Take a look at these. Angles 4 and 6, opposite sides of the transversal and inside the parallel lines. Angles 3 and 5, opposite sides of the transversal and inside the parallel lines. Their property is that they are congruent. So angles 4 and 6 have the same measure, and angles 3 and 5 have the same measure. The next type are called consecutive interior angles. Sometimes these are referred to as same side interior angles. Again, notice that these now consecutive means they're on the same side of the transversal. Okay, so 4 and 5, they're on the same side of the transversal. Interior, they're inside the parallel lines. And then 3 and 6 are also on the same side of the transversal and they are inside the parallel lines. Now these, their property is that they are supplementary, so they add up to equal 180. So 4 and 5 together, they equal 180. 3 and 6 together, they equal 180. The last type that are formed by these parallel lines is called corresponding angles. Okay, and the way that you can think of these is they are kind of made in the same place. Okay, so take a look. Our first set is 1 and 5. Notice how angle 1 is in the top left of the 4 formed at the top parallel line, and angle 5 is the top left in the 4 angles formed on the bottom parallel line. So they're kind of made in the same place. Angles 2 and 6, they're in that top left of each set. Angles 3 and 7 are in the bottom right. Did I say 2 and, hang on, 2 and 6 are in the top right. I don't know what I said, so I got to go back. And then 3 and 7 are in the bottom right. And then finally 4 and 8 are in the bottom left. Okay, so corresponding, I usually try to think of they're made in the same place. Okay, and then their special property is that they are congruent. So that means that 1 is congruent to 5, 2 is congruent to 6, 3 is congruent to 7, and 4 is congruent to 8. Now, you'll probably have noticed also that I listed our angles from last time, vertical angles and linear pairs. Those happen anytime we have two sets of lines intersecting. So we have a lot of different sets of vertical angles, 5 and 7, 4 and 2, 6 and 8, and 3 and 1. Those are all sets of congruent angles that are vertical angles. And then linear pairs. Linear pairs, of course, form a line and they are supplementary. So around each set of where the transversal cuts a parallel line, you have 4 pairs. On that bottom set, you have 5 and 6, 6 and 7, 7 and 8, 8 and 5. On the top set where that parallel line is cut, you have 1 and 2, 2 and 3, 3 and 4, and 4 and 1 are all sets of linear pairs that are supplementary. This is a good visual of all our different types of angle pairs though, so I wanted to make sure to include those because we can still use those properties as we're working through these new things with the parallel lines. All right, let's take a look at some examples. We want to classify the angles given, and then we want to solve for the variables. So the first thing we got to do is figure out what type of angle pair we have. All All right, so we want to take a look at where these angles are formed. Again, they're inside the parallel lines, and they are both on opposite sides of the transversal. So these are alternate because they're on opposite sides of the transversal, interior because they're inside the parallel lines. So we know that they're alternate interior angles. We just said that alternate interior angles are congruent. They have the same measure. So if they have the same measure, then x equals 46. All right, let's take a look at number 2. Number 2, let's see what types of angles we have. They are on the outside of the parallel lines, and they're on opposite sides of the transversal. So these are called alternate exterior. Okay, they're on opposite sides of the transversal and the outside of the parallel lines. Now, we also said that alternate exterior angles are congruent. They are equal to each other. So we know that x has to equal 37. Take a look at number 3. These angles are on the same side of the transversal, and they're inside the parallel lines. So these are called consecutive. I think I missed a C in there. Okay, so consecutive interior angles. We said that these pair of angles are supplementary. They add up to equal 180. So we know that x plus 68 should equal 180. If we subtract 68 from 180, that's going to leave 112 for x. Okay, so 112. Number 4, take a look. Now, these are on the same side of the transversal, but they're not either both inside or both outside the parallel lines. What we should notice about these is they're made in the same place. Okay, so these two are made in the same place. They're the top right of each parallel line when it's cut by this transversal. So these are those corresponding angles. Okay, we said that corresponding angles are congruent. They're equal to each other. So we know that x equals 111. Okay, now all of those were very easy to solve. These can get more complicated as we start looking at more complicated expressions. Instead of an x, maybe they have a 2x minus 3 as an angle, and it gets a little bit more complicated to solve. So I want to take a look at some of those. Okay, we've got 3 examples here. Let's take a look at the first one. Number 5, we've got 2 sets of parallel lines. We've got the 2 sets of angles there showing, or arrows showing us those are parallel. That's what, just as an FYI, okay, those sets of arrows mean those 2 lines are parallel. So if you ever see that, that's all it means. We have a 90-degree angle marked here. We know that this is 90 degrees. And then we have 21x plus 6 as the other angle marked. Let's take a look at these 2 angles. They are made on opposite sides of the transversal, and they're on the exterior. So these are alternate exterior angles. We know that their property is that they are congruent. So we want to set 21x plus 6 equal to 90 and solve. Let's subtract 6. So 21x equals 84. Divide by 21, and we know that x equals 4. Okay, and all we're doing is solving for the variable for these. Let's take a look at number 6. Both of these are on the same side of the transversal, and they're not both either on the outside or the inside, but they are made in the same place. They're both made in that top right corner for each parallel line. So these are corresponding angles, and we know that they are congruent. They're equal, so we can set 75 equal to 11x minus 2. Let's add 2 to each side. So 77 equals 11x. Divide by 11. And now we know that x is equal to 7. Okay, let's take a look at that last one. Both of these angles are inside the parallel lines, and they are on opposite sides of the transversal. So these are alternate interior angles. We know that their property is that they are congruent. They are equal to each other. So we can set 8x minus 4 equal to 60. Let's add 4 to each side. That would give us 8x equals 64. Divide by 8, and now we know that x is equal to 8. Okay, so that's one way that it can get a little bit more complicated and a little bit more difficult when we are solving for variables with these angles. Okay, now I'm going to get a little bit more in depth as well. Okay, this time we have two sets of parallel lines. Okay, we have these parallel lines. We also have these parallel lines. Okay, and then when we are looking at the sets of parallel lines, the other lines form transversals. They're cutting them. Okay, so let's talk about some things that we can do to figure out some variables and some measures. Well, I already can tell 72 and 3y, it doesn't even matter if we have parallel lines. Those are a linear pair, right? So we know that they should be supplementary. So we know that 3y plus 72 should be equal to 180. Let's subtract 72 from 180. That means that 3y is going to be equal to 108. Divide by 3, and y is going to be 36. So we found y. Now, let's take a look at x. Let's see if we can figure out how we could solve for x. Take a look at, there's actually multiple things we could do. Okay, probably the easiest is to look at x and 72. What's the relationship with x and 72? Well, they're both on the same side of the transversal, and they're inside parallel lines, so those are consecutive interior. So we know that they should equal 180. They should be supplementary. So x plus 72 should equal 180. Subtract 72, and now we know that x should be 108. We could have also said that x and 3y are corresponding. So we could have plugged back the 36 in for y, multiplied by 3, and set it equal to x, which would still give us 108. Either way, we'd get the same amount for x. Now let's take a look at the angle that involves z. Okay, 3z plus 18 and x, those are corresponding angles, aren't they? Okay, they're made in the same place of those two parallel lines when they're cut by that top horizontal line. So we know that they should be equal. So we know that 3z plus 18 should equal x. And we already solved for x. We said that x was 108. Okay, so 3z plus 18, let's subtract 18. If we subtract 18 from 108, that's going to leave us with what? 90. So then, excuse me, divide by 3, and we now know that z is 30. Okay, this is an example of a problem where your other answers are going to be dependent on some of your other variable answers. Okay, we could have still gotten x without the y value. Okay, and we can still get y on our own, but that z value depends on whatever we solve for with x. Okay, so this is one where you just kind of have to be a little bit careful and make sure that you are getting things correct. You might want to go back and just check your answers to make sure, especially since another answer is dependent on one of those beginning answers. All right, let's try one more that's similar to that. Here we have two sets of parallel lines. Those are the vertical lines, they're parallel. And then we have two different transversals, so that makes it a little bit different. Okay, we have that horizontal transversal and then the one this way. Okay, so we have two transversals here. Let's take a look at trying to solve. X is probably easiest to solve for first. Let's take a look at x. X and this 90-degree angle, those are corresponding, aren't they? They're made in the same place for the two parallel lines cut by this horizontal transversal. Okay, and we know that corresponding angles are congruent. They have the same measure. So if that one's 90, then x is also 90. Okay, now let's start to try to take a look at some other things. We should be able to figure out that, let's take a look at the two angles that have to do with y. Okay, the two angles that have to do with y. They have inside the parallel lines. They're located inside the two parallel lines, and they are on the same side of the transversal that makes them. So those are consecutive interior angles, which we know are supplementary. They should add up to equal 180. So we could say that y plus 12 plus y minus 18 should equal 180. Now let's combine our like terms. Y plus y gives us 2y. 12 minus 18 gives us minus 6. And then we are still equal to 180. Let's add 6 over. So 2y equals 180. Whoops. 2y equals 186. Divide by 2, and now we know that y has to be 93. Okay, let's take a look at z. Z is our last one. Okay, so z we're going to have to, z is definitely going to be dependent on other answers. So let's think about a few things. First of all, we said that x is 90 degrees. Okay, so that leaves 90 degrees total for these two angles. Okay, total angles for y, or total degrees for y minus 18 and z has to be a total of 90. Okay, so we know that y minus 18 plus z has to be equal to 90. Well, we already solved for y, didn't we? Okay, we had, excuse me, 93. Okay, we already found the measure for y. We said y was 93. So we can go ahead and subtract. Let's plug that in for y. Okay, now let's do that subtraction. 93 minus 18 is going to give us 75. So 75 plus z is equal to 90. Subtract 75, and now we know that z is equal to 15. Okay. So again, that's one where that final answer to find z, it depended on an answer that we got for both x and y, basically. We knew that that x value was 90, so that left 90 when we take it from 180 for those two angles together. Y minus 18 and z had to be a total of 90. So we wanted to add those together. We already knew the value of y, so we could plug it in, and then we could solve for z. All right, guys, those are just a few examples of all the things that you can do with those parallel lines and the angles that are formed when they're cut by a transversal. You're going to do a lot of practice problems with these. Please feel free to reach out to me if you have questions.